Okay, good afternoon, everybody. My name is Charles Nyabeze, and I'm the Vice President, Business Development and Commercialization with the Center for Excellence in Mining Innovation and also with the Mining Innovation Commercialization Accelerator. Today, this is the first of 16 webinars that we're going to host to bring awareness of our approved MICA projects to the mining ecosystem. And today I'm going to be joined here by Dr. Rob Stephenson from WaterStrider Treatment Inc., who is going to be presenting to us a presentation on introducing Amprey to treat water from mining. But before we jump into this presentation, I just want to let you know that we recently approved our projects just last week, in November the 15th, and publicly told the country which organizations will be getting MICA funding. But for the purposes of this presentation, we will be recording it. So a recording link will be made available through our channels. And for those of you who want to type questions or who have any questions, please, you can feel to raise your hand to ask questions, or you can just type them in the chat box. I also wanted to let you know what the other presentations will be over the next couple of days. You can see here the one in yellow is WaterStrider Treatment Inc., and we'll be presenting this proposal to you today. The other 15 will be happening over the next course of this couple of days. So this is them listed here for you. All right. If anyone online wants to know about our next call for proposals, you can see here, we've got a hyperlink for you to click on, so you'll be able to see what the call for proposal that's recently opened is all about. Now, it gives me great pleasure to introduce you to our speaker, Dr. Rob Stephenson, who's going to be presenting to us on the topic of introducing Amprey to treat water from mining. I'm going to stop sharing my screen now, and I'll hand it over to Dr. Rob. Dr. Rob, please go ahead.
Thanks, Charles and Vanessa. It's a delight for me to make this presentation. I'd like to tell a little bit about WaterStrider and what we do. We're a Canadian-based company that we developed clean technologies for treating water from using electrochemical, chemical, and physical methods to basically address some of the issues with for resource extraction that have some of the biggest environmental impacts around. And that's what we've chosen to do. So we're environmentalists that have got the skills to fix it. For mining, what we've done is we've looked at the massive scale of operations, the contaminant levels. And that means that treating the water from resource extraction offers the greatest potential to reduce impacts on the environment. And we're doing that because there's tremendous amounts of acidity and toxicity caused by dissolved metals in treated mine water. And that regulatory compliance requires that we operate lawfully. And if mines could operate cleaner, more effectively, then they could remove some of the current roadblocks that currently constrain their roadblocks of water quality that constrain their initiation. Currently, lime is the way that most mines treat their water, and it has all kinds of issues with it in terms of not all the contaminants can be removed by lime, and that if you have multiple dissolved metal contaminants, it requires many stages and it causes GHGs. You can't run the system at cold temperatures. You can't select the lime at -3, and you generate huge amounts of sludge that creates a large environmental liability and cost. And also the systems are big. Now there's lots of other ways of managing this water, but suffice to say that none of them are completely effective and have major environmental and financial issues. So rather than using lime or sulfide, another way to treat water, or also to use iron in separate stages that are complicated and expensive, our technology called Amprey has basically not individual bullets, but all in one. And this allows us chemically to form metal hydroxides, which are really important for treating water from dissolved metals from mines. It also allows us to form sulfides and carbonates. This is another way to treat water, and some of the contaminants come out that way rather than the hydroxide. It also allows us to form coagulants and co-precipitates. So we have all these methods in a single process with Amprey. So in just a single step, we produce all these chemistries, but nobody else does this. And so what we have this upflow packed bed that's electrified. And by doing that, it allows us to remove many contaminants, and many contaminants are really difficult to remove otherwise. As well as we produce very small amounts of solids as a waste product for disposal. And those solids are incredibly non-leachable and very dewaterable. This is what the cell looks like. We use an electrically activated metal pellet packed bed. And this allows us to treat water that's even not very conductive at all, and also cold water as well. It doesn't take a lot of electricity, and there's really no moving parts. We can scale it to basically any size, and the pellets you can see here of pouring into the cell, those are easy to replace. And so depending on the contaminants we're trying to remove, we either use pellets made of aluminum, steel, or magnesium. And even better, we use recycled metals whenever possible. And that has tremendous benefits also for greenhouse gas impact. This is a little bit more detail what it looks like inside the cell. You can see my hand on the right-hand side, holding on to the magnesium pellets and the steel shot. And so what we do is we electrify this material, and it causes all these delightful chemical reactions that allow us to remove dissolved metals from mines. Now, this is a barge that washed up on the beach in Vancouver about a year ago, and I thought it could teach us a really important lesson about how to treat water for mining in particular. So inside that barge, the steel rusts, and as it rusts, it consumes oxygen from air, and this creates what we call reducing conditions. Basically, it's a deficit of oxygen. And so what we do is we mimic that same chemistry in the barge, and that allows us to remove selenium, which is a huge ticket and a huge item, certainly in regulatory issues for mines in Canada and throughout the world, as well as other metals such as arsenic and antimony. And so what we do, we dissolve these steel pellets and we introduce the iron. We also create these reducing conditions, and that's necessary, in particular, to remove selenium from its less soluble form. And this is an issue, especially with regards to coal mines in Western Canada. And that once we cause those reducing conditions to change the form of selenium, it also allows us to attach the selenium or arsenic or antimony and other metals and attach it to this ferrous iron. And then what we do is we change the ferrous iron to make it less soluble, and we separate it. Sounds really easy, but I guess part of the magic is making it simple. So what we've done is we've created 3 technologies that they work together in different ways. And so we've talked a little bit about Amprey so far, about the electrifying the pellets to create all these conditions. We also can, having dropped the redox potential, we can also raise it by using a technology called MICA, which is a spring mist recirculation system. We can also use carbon dioxide gas to neutralize pH, because often we're changing the pH to extremes in order to treat the water and remove metals. We can separate the solids using our microbubble system called microform, and this also allows us to contact gas. And the combination of these three technologies of Amprey, MICA, and microform allow us to be able to remove a whole suite of metals from any mine or coal mine, and do so at a lower cost more effectively than other systems. One of the aspects in terms of treating water from mining is that these solids, the metals don't go away. They are concentrated and they have to be disposed of, or preferably recovered if possible. And so minimizing the volume of solids is really important. And one way of doing that is not creating very many, as well as making sure that you can do water and take the water quite easily. And it's also really preferable, especially if these are waste, that they become non-leachable, that they don't dissolve upon storage. And if we can do that, that's going to provide us with lower costs and liabilities. You can see here, this is using a filter press. It produces these solids that almost look like kitty litter in terms of how dry they are. So we're based in Vancouver. We're made in BC mining innovation. We've got intellectual property around the technologies we've shown you. And thanks so much to MICA for supporting us. We've also received other support for technology development from groups like Environment Canada, the Ontario Federation of Agriculture, the Innovation Council of BC, and the National Research Council of Canada. So, pun intended, we believe our results are electrifying. These are examples of a gold mine in northern BC, where we're dropping the permit levels down significantly. Our biggest challenge here was removing cadmium down, because it's basically down to non-detect levels, and we nailed that. So we're really proud of these results, and this mine is going to go full scale with us in 2023. We're really excited by that. We can also take selenium from coal mine water, as you can see here, dropping by over 98%. Here's a higher level of arsenic, also from a gold mine northern near Whistler, BC, as well as some of what we do is not just contaminant removal, it's also a consistent recovery. where we can remove lithium from brines and oil gas produced water by an extraordinarily high degree. And this has got some economic value rather than just a contaminant. So it's a useful product. Here's some recurrent projects. Excuse me. So looking at selenium removal, lithium recovery, and uranium removal from mine water. And we're doing this at bench, pilot, and full scale. This is what the MICA demonstration project will look like from an aerial view. And so we want to focus on the more difficult to remove contaminants, and those would be selenium and arsenic and other dissolved metals. And this is not to be kind of test tube size. This is showing 100 liters per minute so that the portion of scale up is relatively straightforward. And ordinarily would expect at most mines to scale it up in the neighborhood of 10 to 50 times. And what we're seeking now are demonstration hosts for up to 4 mines in Canada over the next couple of years. We want to do that on site where we can show how the technology works, generate the results, and have that lead into commercial opportunities for us. So we believe that Amprey is an ideal solution. It allows us to allows us to move metals in a whole variety of ways that can be very effective to meet compliance. When we form the hydroxide and the sulfides, as well as the iron and creating the solids, we can increase or decrease the redox potential. We can increase or decrease the pH, and those are the 2 levers to treat basically any water from mines. And also we've got useful solutions to separate solids and do water with solids. We do it simply, and that's part of the innovation here. We can do it simply. We can minimize the chemical requirements at all and minimize the waste for disposal, and that those that are produced are stable. And this allows it to come up with the lowest cost practical. But we want to lead, not just follow. We want to show that we have a technical innovation that can be useful in Canada, and that we can show the world how to more effectively treat water from mining to protect the environment and decrease costs. We think this is going to reduce roadblocks to responsible resource extraction caused by water quality issues. And we're doing this to protect the environment, to treat the water to exacting standards and low carbon intensity inputs and reducing GHGs. In some cases, we recover value by recovering lithium and hydrogen and treated water for use rather than disposal. And we can save costs to conserve landfill space, minimize solids disposal, and decrease bonding requirements. But overall, and this is where we really sync with MICA, we want to be part of an innovation ecosystem where, as an environmental technology developer, we collaborate with mining for everyone's benefit. So one of the questions we have is, what do we want from MICA? So we want to understand the mining industry better, both in Canada as well as internationally. We would like to make connections with other organizations and people who are innovating within the mining industry in Canada. We want to know where mines have a specific problem, both technical and cost, and where a successful demonstration could lead to actually us living there full time. As well as, quite frankly, we're a relatively new company, and we're always looking for investment because we have, big dreams. That's my presentation. I'd welcome questions if you have any. I'll try to answer them, but thank you.
All right, thank you very much, Dr. Rob Stephenson, for that presentation. You know what? Maybe you should leave that slide up for now, in case people want to be able to get your contact details. I think it works really great. Okay. So thank you again for the presentation. So what I'm going to do now is I'm going to unmute the guest that we have on the call and ask if anybody wants to ask a question. Please just go ahead and ask a question. But while people are thinking about asking a question, I'm going to ask a question about the differential value proposition. So, Dr. Stephenson, when people say things like, your technology, there's maybe others that do similar things, how do you answer them when they say, tell us the specific differential value that you're offering that others are not offering? How would you answer that question?
Yeah, thanks for the question. So doing what we're doing, we can provide all these chemistries all at once in a really simple way. There are some other groups that are doing electrochemical treatment. They often require high conductivity. They also are limited by scale. Our system is a pack bedded system, and so it looks, in a way, it almost looks like a media filter, like a sand filter. with a whole bunch of electrodes in it. So we can go to whatever scale we want. So we basically have the full spectrum of chemistries to treat any dissolved metal from mining. And we do it simply and lower cost than anyone else.
All right, thank you for that. Okay, again, I'm gonna open up the floor to anyone else ask a question. Please go ahead.
Yeah. Hi, Dr. Rob. Thank you for that. It's certainly very interesting. I was wondering about whether you can scale up to treat mine water at large volumetric rates.
Yeah, the system itself, basically it's an upflow packed bed system, which maybe not, I don't know if that makes any sense to you, but it's almost like a sand filter. We can go to any size. The maximum size, because we have to pair it with electrical supply, the maximum size would be in the neighborhood of about 4 feet in diameter and about 8 feet tall. So it can be basically fit into transportable containers. And then as we need greater capacity, then we line these up almost like the nutcrackers that are a mantelpiece for Christmas. So you line these up, you have multiples of them. And so each one of those systems can provide somewhere between 500 and 1,000 liters per minute. And so if you've got 20 times that, you put in 20 nutcrackers side by side.
Oh, gotcha. Yeah, thank you for that answer. And Dr. Rob, this is a question that we often hear from the mine operators, is the idea of scaling up and the ability for you to meet the demand. And I'm glad your technology is scalable. My next question, Dr. Rob, is concerning return on investment. And this is a question that comes up quite a bit. How do you quantify the return on investment on a mine operator adopting your solution?
Well, we have to characterize. I mean, we're not creating a revenue, we're decreasing costs. So what we'd have to do is to look at what's required in terms of their ongoing costs and compare that with the cost savings that we provide with our technology. In some cases, we'd be willing to provide the system and provide ongoing operations. So there's not a capital investment per se. Not all mines will be interested or want that. So we're flexible in terms of how to provide that. But basically, we're looking at cost savings, both in terms of the ongoing operating costs, and not to be ignored is the ongoing liability of the solids that are being produced. You know, for example, if you're running a lime system, there's a tremendous amount of solid being produced that are sitting on someone's balance sheet, and there's liability to be paid. So those are important factors. It's a cost reduction, and so we're always comparing versus conventional systems, and we have to provide a compelling benefit.
Okay, thank you very much for that answer. All right, again, opening up the floor for someone other questions. Please go ahead.
I was wondering, since Charles brought up mining operators, so what kind of commitment would you acquire from the end user at this stage?
Well, we're looking for host sites, and our best host site is one that doesn't want us to leave after we finish. So we're looking for host sites not just simply as a kind of an academic study, but a host site that truly has an issue with regards to performance and or costs concerning treating the water. And what we're hoping that the best recommendation of any kind of demonstration as we're providing is to say, you know, please come back at full scale in a permanent system. That's by far the highest endorsement. That's what we're seeking. So we're looking for hosts that have a technical and or cost issue with treating the water from mining, and that we'd like to have the opportunity to show what our technology can do and the benefits it can provide.
Awesome, thank you for that. I like how you sort of narrowed down to a host with a technical issue and a cost issue. I think those are two really important ones. Okay, my next question to you is concerning the speed of installation. And the reason I ask this question is many mine operators are very concerned sometimes about the time it takes to implement a solution. And if they can know upfront what the expectation is on implementation timeframes, that would really be useful. So maybe if you can just shed some light on that. Somebody wants to adopt your solution, how long should they expect the process to take?
Yeah, that's a great question because, you know, as we all know, mines are often in remote areas, and then providing the infrastructure for a water treatment system will often be quite onerous and long. And the longer it takes, the longer the delay is between all these expenses and actually generating revenue from the minerals that are being mined. Having said that, our system, it can be modular, so we can put the system in transportable shipping containers, so that we do not require civil infrastructure to do that, other than simply some footings or even very simple footings to support the system. So we can install a system within a year of coming up with a specification for it, and then we'd install it, and the installation itself would be basically transporting the containers to site, doing the interconnects between the containers and to the water supply, and then the treated water discharge, as well as connecting to power. So it can be very fast. Basically, one of the aspects we have is if you don't like how fast the water treatment system is operating, you give it more power, and that's part of the magic of electrochemistry. It's quite compelling.
Okay, all right. Thank you for that answer. Appreciate that. Okay, again, opening up the floor for other questions.
Well, you mentioned something about support from the MICA network, and the MICA network is really made up of players from the mining ecosystem. Just to understand better, what are you hoping to gain from MICA support and from our network and our growing membership model and the ecosystem at large for your project?
Well, I think you've attracted a lot of really smart people. We attended the event last month, and there's a lot of people with some tremendous ideas that can, where we can work together to solve some problems. I don't believe that we're uniquely smart or innovative, and that there's lots of other groups that do that. And sometimes we'll find some ways that the various technologies can work together. So that's very helpful. My profession, I've worked in water treatment for my entire life, but treating water from mining is relatively new to us. So we're not intimately familiar with who's who in the zoo, the various mines, where what their challenges are, and who the drivers are, and who the innovators are. And we're hoping that MICA can help identify some of the potential collaborators and also some of the potential users of our technology.
Awesome. Thank you for that answer. And I guess maybe in the interest of time, maybe one more question here. And, the last question I have for you, Dr. Rob, is do you have any demonstration units available for people to come and take a look at? And the reason I ask the question this way is, this industry that we are in, it's a show me industry. People want you to show them something, right? So maybe you can answer that question. If somebody wants to see the technology in action, do you have something available for them to take a look at, something they can touch and see, to see that it's real?
Yeah, thank you. We have several stages. We can show just at the bench scale, which is not as compelling, but we're just finalizing the plumbing of we call our mini pilot, and this is based in Lower Mainland in Vancouver. And so we can bring in batches of water, call it a couple of cubic meters at a time, and show on a continuous basis how the system works. And we completely agree it's a show me system. Some of the things that we found electrochemically, I never would have thought that it would happen, but it does. And more by good luck than anything else is that a lot of the things that are going on electrochemically are really helpful in terms of removing metals. So actually having people see it even at a small scale, and then look at, okay, what's happening to the pH, what's happening to the redox potential, and they can actually sample throughout the system. So we actually are commissioning that this week, and we'll be operating the system as early as next week. So that complements our bench scale system, as well as it also complements the work that we've done up at a mine near Smithers, where we've run this. I think we've run about 700,000 liters of water through that system, and so we're in the final permitting process to have that as a full scale permanent installation. So we have 3 levels, and we welcome people to see it, because I'm the same way. I'm a skeptic until I see it. So I need to see it, and
Awesome.
You can do all the hand waving you want, and I want to see it. So we share that concern.
All right. Well, I was just want to thank you, Dr. Rob, for this presentation. And just for the people watching this online, I just want to remind everybody that what we're going to be doing is we are going to be doing 15 other presentations on the companies that you see listed here on this page right here. And those will be happening over the next couple of days. And again, if you want to get more information about our second call for proposals, you can just point your camera on your phone to this QR code right here, and it'll bring you right to the site. And again, I just want to thank Dr. Rob Stephenson for the presentation on WaterStrider's introducing Amprey to treat water from mining. It's a tongue twister for me a little bit there.
I'm sorry. Yeah, yeah. Sometimes the names aren't user friendly. Anyways, I appreciate your interest. It was a pleasure doing it, and we very appreciative of the support from MICA. I think it's a great idea, and we're glad that you like what we do.
Thank you so much, everybody. You take care. All right, thank you, Dr. Rob.
Thank you.
Bye-bye.